Hello, everybody. I hope you're having a good time. Today, I'm going to talk about deep learning and how it can be used to make art. Technology has always been a great enabler of art. We've seen that through electricity, music, synthesizer, photography, and all that. And deep learning as a new trend and new awesome technology we see emerging, well, it enables art. So before speaking about everything, let me introduce myself. My name is Guillaume Sanchez. I'm a PhD student at the LIS in the University of Toulon in France. And I'm an AI research and development engineer at Hexaglobe. We are located in France. And you can see us in the hall 14, booth A16. So we hope to see you there. So AI now works mainly with neural networks. But what is a deep neural network anyway? A deep neural network is, for image content, is a series of detector and classifiers. So, for instance, on this diagram, you have on the left, like you have a small purple rectangle. Let's say this is an image. And this image will go through a series of detectors. Like, for instance, the first detectors will detect like small edges, gradients, bright zone, darker zones, all that you can see, like you can see there. And then the next detectors will reuse these results to build on top of that. So for instance, if you have an horizontal line and a vertical line, it can deduce that this might be a right angle. And then the next layer of detectors can see that if you have 4 right angles, well, this is maybe a square, right? And here you can see that with like small edges, then face parts, then full faces. So it's a hierarchical process, right? The thing is, when we're going through the layers of a deep neural network, well, the first few layers are interpretable. We can understand what's happening. But as you move through the layers, the pictures you can see makes less and less sense to us as humans, because the neural networks learns to do stuff that we can't understand yet. And that's a problem, because if we can't understand what it's doing, it means we can't really improve on that. We can't really manipulate that. So that's an issue. And researchers are doing a lot of work to understand what's going on. And one of these trials was simply to try to tell, well, what does this neuron detect, right? So that's called feature visualization. And you do the opposite process. You choose a neuron in your convolutional neural network. You propagate back to create an image that maximally excites this neuron, and you get these weird-looking pictures, right? So if you excite the neuron that detects lemon, that's what you get. It's not super pretty. It's not super interpretable. You don't get to understand really what's happening there. So it's low value, right? But if you tweak the algorithm a bit forward, use better mathematical formulas, well, you get that. So sit back, relax, enjoy the pretty pictures. So we can have some glimpse of what's happening, right? You have a neuron that detects weird and mean eyes, or something like that, some kind of snake skin texture, some really weird stuff that I cannot understand what that is, or, well, I guess that's part of a toaster or a truck, I'm not really sure. But we don't have control about that, right? That makes like great abstract art, but we don't have any control on that. So if we use some more filters, we can be able to have better looking pictures, but that's it. So some researchers at Google tried to understand a lot more what was happening in the deep neural network. So they had this idea where they took a picture, they went to go through the neural network, and then they just said to the neural network, OK, whatever you're seeing, just make it bigger in the image. Just improve it. Just increase it. And, well, you got that. So not much for art, right? So you can see some eyes spawning there. So here we improved mainly some local small features, like small details, like edges, stripes, all that. But we can make that happen in deeper layers that learn more abstract things and more global things with more meaning and more semantic things. So like take this pasta, for instance, and I'm sure now you don't want to eat them. So what's happening there? Well, our neural networks turns out to be obsessed with eyes because it's actually obsessed with dogs because it's been trained to detect among several breeds of dogs. So it learned a lot about dogs and about dog eyes and dog's nose. I don't know how to say that in English anyway. So that's what you get. And another example, so that is a friend of mine. I hope you think she's cute because now, well, not so much. So what's happening? Some really interesting stuff also. You can see on the chair that the neural networks actually never seen that kind of chair without someone on it. And so it automatically added someone's face somehow, like the pink circle. Well, the trees turned into a dog also somehow. The water into some kind of bird. And on the pool, I don't know what it created exactly. Maybe it's mechanical stuff. Maybe it's pole dancing. I can't really tell. But well, still, that's interesting. That makes some abstract art, and actually some people are building that and are selling that, so that's interesting. But we don't have any more control. And in 2015, Leon Gattis released a paper that made a lot of noise in the media and the researcher community because they managed to make this kind of interesting artwork. So what is that? You take a picture on the left, for instance. You take an art piece on the right, and well, it mixes the two to have your content, but with the style of an art piece. So that's an example I made especially for you guys. And how does that work? Well, you take your pictures, you make it go through a deep neural network, you keep some layer activation, meaning what the neural network understood from your picture. You do the same with your painting. You store it, you compute some statistics, and then you optimize an image to match what the neural network saw in your content picture, but also match the style and the statistics it's seen in the style picture, and that's what you get. And this is where the pictures released in the actual paper. So in the top left, you see the pictures that use as content picture, and you can see several art styles. So you can see Starry Night, The Scream, and some more stuff. I don't know a lot about art, so that's what you get. And some people built on that and created Neural Doodle. And Neural Doodle is a really funny thing. So you take a painting, still the same, but then you take your favorite image editor, like Paint or GIMP or I don't know, and you create what's called a semantic map. And a semantic map is like just you use one color for one stuff. So like you have the blue for the water, the brown for the ground, the gray for the rocks, and all that. And you have in your network learn the correspondence between both. And then you can paint a new picture, a new semantic map, like you see on the top left, on the bottom left, to generate back a new painting in the same style with the same elements, but now that looks like yours. And some people from Adobe continue to build on your artistic style, and now they manage to have Captain America as a gladiator. So you can copy-paste anything from a natural image, put it on a painting, and it's integrated in the painting, and they use that to put cell phones into historical pieces. That was really funny. Well, paintings are great, right? But photographers are a bit left out because, well, you want something that looks realistic, right? And with painting, they distort a bit your image. The shapes are not totally preserved. So, well, you want something that works with pictures. And so some researchers from Adobe managed to have transfer style, but from images. And that's what you get there. So for instance, on the top left, you have a daytime picture, then as a constant image, then a nighttime picture as a style image. And then you have your daytime picture at night with the same colors and lighting styles as your content image. And that can be used for lots of stuff. Like, for instance, you can see some bad weather, bad contrast, bad colored pictures turned into beautiful blue sky, green grass, because, well, the style is better looking. So, pretty cool, pretty beautiful, right? But sometimes you want to create more. So some researchers build an algorithm that's called pix-to-pix, and we'll see how that works. But first, let me introduce a new kind of more sophisticated neural networks, and that's called a GAN, for Generative Adversarial Network. And that works as follows. You have a neural network that's trying to build an image, but you want this image to be realistic. So how do you enforce that? Well, you have a second neural network that learns to distinguish between generated images and real images. And so they'll learn conjointly, And when the discriminators know that the fake image is fake, it can tell the generator why. And the generator can learn to fool the discriminator more, and this is a constant battle between both. The generator becomes better at fooling the discriminator becomes better at distinguishing fakes. And in the end, you can have things like that. So those people trained again to convert edges to, well, shoes, handbags, and all that. Great tool for designers, by the way. So you can paint whatever you want, as long as it has approximately the same shape of what you expect. It invents and creates the details it's missing, like the colors, like the material, and all that. So you can now draw shoes, handbags, and, well, cats, because the internet is all about cats, right? So I gave it a try and tried to draw my own cat, but I'm not a great drawer, so that's what I got. So that's it. And we can go further, because why stop there? So let's say you want to turn zebras into horses. Nobody really cares about that, but that's the example they used in the paper, so yeah. So you have a bunch of pictures of zebras, a bunch of pictures of horses, and you have a neural network that tries to convert your zebra picture into a horse picture. To enforce that this picture looks good, you have a discriminator that says, OK, this is a real picture of a horse, or this is a fake picture of a horse, right? But, well, neural networks are not that dumb, and if you just enforce that your pictures should look like a horse, that means it can create any horse image and totally discard the zebra input, right? So what we're actually trying to do is to have the image as close as possible from the zebra image, but turn into a horse, right? So what we're doing is we're converting back the horse image into a zebra image, and we try to have exactly the same picture, so that the neural network is forced to make a horse picture that looks like the zebra pictures, and change the less amount of things possible. So nobody really cares about horses and zebras, but previously we've been able to turn photos into paintings. Now we can do the opposite also, because we have both ways enabled by that. So that's quite awesome. We can turn zebra into horses, horses into zebra, model it into photo, and paintings to photo, photo to painting, winter to summer, anything. Like, we had pictures also turning themselves into other people. And they're doing it in videos in real time. Because, yeah, why not? So this is another example. They're turning Grand Theft Auto screenshots into, well, real-looking pictures. And you can go forward. So technology is always moving forward and doesn't stop here. So this is, last but not least, what's happening in the community. So this example is actually from 2 weeks ago. So that's fairly recent. And it's called Everybody Dance Now. So I am personally not a great dancer. This is quite the euphemism. I'm terrible at dancing. And thanks to AI now, I can dance like a professional. You can have a source video of someone dancing or doing moves, and you have neural networks that detects how this person moves, that you see there, they construct like the bone of the body. And then they turn your own pictures, your own video of you just doing random moves, but now it's forced to generate pictures of you that have the same body position of your source video. So it's forced to make you actually look like you're dancing based on the same GAN architectures. So that's what you get. That's a video. I cannot display video here, so that's PDF. I'm sorry. So what's next? Well, we want to create from textual description. But text and language is ambiguous by nature. So this is hard, and we're not there yet. We need some better temporal coherence in video. Like, if you create videos, you have some artifacts, some flickering between frames. So we're not there yet, but it's improving at an increasing pace. That's really amazing. Even what we got last week, a new paper, was pretty amazing. We want even more control about what we can do. We want to enable or fine-tune some things. We want to be able to generate music. What we can already do, if you listen to sample from 5 to 10 seconds, it creates awesome music, but it misses the global coherence, like the whole structure, like verses and choruses. We can also have super resolution. You take a low-resolution image, and it improves it by imagining the details it was missing. You can have some more Photoshop tools, like in painting. If you don't want some people on a pretty landscape, well, just erase it and have in your networks just invent what was missing there. So we can create all that. And, well, science is not done yet. It's always going forward. So whatever you can think of, well, just try to make it. Thank you for listening. You can see me later in the panel. And tomorrow, I'm giving another talk about deep learning and security, where we learn how to launch geopolitical conflicts and all that, thanks to deep learning.
Oui.